on this part of the lesson, we will talk about molar concentration. Ion concentration. What do we have to keep in mind is that when we have a balanced reaction, then the coefficients that are in front of the compounds are telling us the molar ratios. So you know this. So if we have a concentration, like a balanced equation, let's suppose that we have this balanced equation here. R3 plus H2SO4 will give us SO4, 2, SO4 plus HBr. When we balance this, what we have in front of iron bromide, we have 2, and then 3, 1, and 6. What does that mean is that 2 moles of iron bromide will react with 3 moles of sulfuric acid to produce 1 mole of iron 4 sulfate, iron 3 sulfate, and it should be iron 3 sulfate and 6 boric acid. So now, always when we are working with either products or with products and reactant, or reactant and reactant, what we use is we use those molar ratios here. So if, let's say, we are going with iron 3 bromide and boric acid, then the ratio will be 2 to 6 or 1 to 3 in the lowest term. Well, let's see now how can we determine the ion concentration when we have a molar ratio of 1 to 1. What is the concentration of each ion with a concentration of 0.0871 moles per liter in a solution of sodium chloride? So now what we have is that we will write a reaction. Now, on this case, will be a dissociation reaction because sodium chloride in water, how do we know that it's in water? Because it is, we have a molarity over liter, and it is in water on almost 100% of the cases will be sodium ion and chloride, so in aqueous solution. Okay, so now what do we have here? The ratios, this is balanced, is 1 to 1 to 1. Okay, so now we have here the concentration of sodium chloride is 0.0871 moles per liter. That means that the concentration of sodium ion will be 1 to 1, so 0.0871 moles per liter times, and this is moles of sodium chloride. Then we have 1 mole of sodium chloride is 1 mole of sodium ion. So moles of sodium chloride and moles of sodium chloride is cancelled out. And then what we have here is 0.80871 moles of sodium ion per liter, which means that the concentration of sodium ion in dissociation of sodium chloride when we have the solution is the same as the concentration of sodium chloride. Next one will be 0.0871 moles of sodium chloride per liter times the molar ratio of sodium chloride and chloride ion. So the ion of the chloride will be 1 mole of sodium chloride is 1 mole of chloride ion. So then canceling out moles of sodium chloride, we will have the concentration of chloride as 0.0871 moles of chloride per liter, or molarity. You can say that molarity as well. Okay. Now, let's take a look when we have a compound. So we have ammonium sulfate. The ratio is not 1:1. So we have an ammonium sulfate. Let's write a dissociation equation for ammonium sulfate. So the dissociation equation will be NH4, so 4 in solid will be dissociated into 2 NH4 plus SO4 2 minus, and they are in aqueous solution. And now what we have here is that the concentration of ammonium sulfate is 0.0636 molarity. And we are looking for this first, and then we are moving to this one. Okay, so now as we see here, the molar ratio between ammonium sulfate and ammonium ion is, sorry about my dog, but this is what is happening when we have, okay. So now we have the ratio, I was saying that the ratio between ammonium sulfate and ammonium ion is 1:2. So as you see here, 1 mole of ammonium sulfate will produce 2 moles of ammonium ion. Polyatomic actually ion, but okay, so now we start with 0.03636 moles of ammonium sulfate per liter. That is the concentration times the molar ratio. So the molar ratio will be 1:2 or 2:1. And what are we using is, in order to cancel the moles of ammonium sulfate, we will use 2 moles of ammonium ion over 1 mole of ammonium sulfate. So moles and moles of ammonium sulfate is cancelled out, and then we will have a concentration of ammonium ion as NH4 as 0.127 moles of NH4 over liters, or you could say just simply moles of NH4. Now, when we are working with molar concentration of sulfate ion, then we always will start with what is given, 0.0636 moles of ammonium sulfate over liters times the molar ratio, and on this case we will have 1 mole of ammonium sulfate and 1 mole, because the ratio is 1:1 on this case, 1 mole sulfate. So moles of ammonium sulfate is cancelled out, and then the concentration of sulfate will be 0.0636 moles of sulfate ion. Okay, let's see now what is the concentration of each ion in a 0.500 solution of lithium sulfate. Okay, let's start with balanced ion dissociation reaction. So we'll have Li2SO4 and solid state. When we put it into a solution, will be 2 lithium in aqueous solution plus SO4 2 minus in aqueous solution. So now this is balanced, 2 lithium, 1 sulfate, 1 sulfate. Good, so now we start with 0.500 moles of lithium sulfate over liter, which is the molarity times. And first we are looking for lithium ion. So ratio will be 1 to 2, meaning that 2 moles of lithium ion are as a result of 1 mole of lithium sulfate. So moles of lithium sulfate is cancelled out, and then we will have a molar concentration of 1.0 molarity for lithium ion. And when we are calculating the molar concentration of sulfate, we'll start with, again, with what is given, moles of lithium sulfate over liter, because this is the concentration times. Now the ratio is 1 to 1, so 1 mole of lithium sulfate over 1 mole of SO4. So then we will have 0.500 molarity of sulfate. Now let's determine the concentration of compound from the concentration of the ion. So the concentration of solute ammonium phosphate will be required to produce what is the concentration to produce ammonium ion of 0.9. So this is the concentration of NH4 plus. Okay, so now let's write a dissociation equation. So we have an ammonium sulfate here. That will be NH4 PO4. In a solid state will be 3 NH4 plus and PO4 3 minus. So now we have the ratio between the ammonium sulfate and ammonium ion is 1 to 3, because this is a balanced one. Now what do we have here is the concentration of ammonium ion as 0.918 moles per liter of ions, and we are looking for what is the concentration. So what is the concentration of? So we'll start with what is given, 0.918 918, and then this is moles of ammonium ion over liter times, using the molar ratio, we'll have 3 moles of ammonium and 1 mole of ammonium sulfate. So moles of ions is cancelled out, and this will be whatever is 0.918 divided by 3 is 0.16 molar concentration of ammonium sulfate. Now, when we are determining the mass, this is the most difficult level. So now we have determining the concentration of each ion. If 35 grams of ammonium sulfate is dissolved in 2 liters of concentration. Okay, good. So let's start with writing a balanced equation. So I will write it here. So NH4, 3PO4 in a solid state will be 3NH4 plus PO4, 3 minus. And they are in aqueous solution because you are dissolving them. Okay, good. So this is the balanced dissociation equation. How do we know that it's balanced? You can check how many of each of them you do have on both sides. And if they are equal, like any balanced equation. Okay, good. Now the molar mass of ammonium phosphate is 149.12. You can calculate it. 149.12 grams per mole. Okay, and now we are looking for, this is dissolved in 2 liters, so 2 liters. Okay, let's start with finding the molar. We are looking for concentration of each ion. So we'll start with NH4 first. So concentration of NH4 ion. Okay. It doesn't matter what it is. We always will start with what is given. So we have 35 grams of ammonium sulfate, NH4, 3PO4 times, using the molar mass, we will find what is the number of moles. So 149.12 grams of ammonium sulfate, 1 mole. So now what we have is the number of moles. Those number of moles are dissolved in 2 liters. So then that means that 1 over 2 liters. So now up to this point, what do we have is moles per liter, or molarity of ammonium phosphate. And now what do we do to move to the ion? We will use the ratio. So now we have 1 mole of ammonium sulfate is giving 3 moles of ammonium ion. So moles of ammonium sulfate and moles of ammonium sulfate is cancelled out. So what do you have up to here? You have moles of ammonium sulfate ion or liters. And this is what the concentration of ammonium sulfate ion, ammonium ion will be. And now what do you do in your calculator is 35 times 1 times 1 times 3, divided the whole thing by 149.12 times 2, and you should have a 0. So let's write it like this. The concentration of ammonium ion will be 0.351 molarity of NH4+. Doing the same calculations, you should have for the concentration of PO4 a 0.117 moles molarity of PO4 3-. Okay, let's see now. Determine the concentration of each ion. Potassium sulfate now is dissolved. You can try this on your own, but what you will have, you can try this on your own, and we will deal with it when we see each other in class. After this, you are free to complete, after this part of the lesson, you're free to complete the assignment on lesson 1. But take it easy because there is a lot of information, so don't worry don't have the tendency to complete it in one day.